All right, welcome everybody. Mike and Artem back. We're here with another webinar. So today we're going to do from CI to Kubernetes. Oh, go back, Artem. Let me do the from CI to Kubernetes catalog, a practical guide to vCluster and GitOps. And then I am Mike Peterson, senior technical marketing engineer, Loft Labs, vCluster, a lot of open source stuff. But I'm going to hand it off to Artem real quick because there's a lot of stuff to get through. Yeah, post your questions and stuff in the Q&A, and I'll try to ask some of them as we go through. But let me go and hand it off to Artem with that. Let's go, Artem.
Yeah. Hey, happy to be here. My name is Artem Laiko, working for ATS Consulting. I'm certified Kubesanout, ambassador for platform engineering, and published author of implementing GitOps with Kubernetes. Let's jump directly to the target and to see what you're going expecting today. First, we are going to clear some terms, understanding what vCluster is, recap use case from our last webinar and why we are doing this webinar and this format, and also giving you an architecture analogy, how to build a Zen story building in 28 hours, what are composable platforms, how we are going from CI to catalog, and also giving you a short live demo to seeing how it looks like on the real world, on the practical world, and giving you some outlook and what's next. So first, let's clear some terms. If we are speaking about catalog, we are not meaning Helm charts or Helm umbrella charts or something like this. We are meaning, for example, if you need Terraform models to provision your infrastructure, then you maybe need Helm charts to provision some tools or deploy some tools. And maybe you have a custom catalog for your software development tools. You wanted to provide it. This is what we a collection of different parts. This is what we call catalog. If we are speaking about Compose, it's not Docker Compose. We are speaking here about, for example, collecting a lot of resources, make him abstract them and make him usable for the end user with just few values, like you already know from Helm charts. vCluster, I'm going to show you what vCluster is. Then if we are speaking about GitOps, we are meaning the continuous delivery part, in the most cases with Argo CD, that is going to be deliver the software, bringing it from your Git to the end cluster. I'm not going to explain Git at the moment. You just need to have in mind that with GitOps, it's meaning we push something to Git and Argo CD gonna deploy it. And if you're speaking about continuous integration, then we are meaning, for example, all pipelines for building the application, putting into a Docker container, building the manifest, doing the test, everything the developer and we as a platform engineer doing in the CI pipeline. And if we are speaking about multi-tenancy, we are speaking here about multi-tenancy based on Argo CD or multi-tenancy. For example, if we have hard multi-tenancy, I call it with dedicated cluster. So every team get a dedicated cluster. If we have a software multi-tenancy, so maybe you have a shared cluster with some rules, with some boundaries, but not maybe a shared node, so they can break through. This is what we are meaning with multi-tenancy. I think we are done with the terms, and it's going to help you to understand the rest. If you're looking at vCluster, what is vCluster? vCluster is like, you can imagine you have a data center, you have Kubernetes running on top, and then you put vCluster on top. Very easy. I mean, it looks like too easy. Of course, it's not like just this. It's look a little bit more like this. You have a host cluster or a managed cluster, and then you can deploy vCluster over an Helm chart and, for example, create a dedicated node pools and create taints and toleration. So you have different versions of K3s, K8s, and binding it to the node pools. This is how we're gonna do it, or how we have already done for the demo. So this is vCluster, the light way. If you have a lot of questions about vCluster, it's of course a little bit more, but this is how we are going to use it. And I think it's going to be all right to understand the rest. So understanding Compose. What we are meaning by Compose, if we are, for example, looking at a cloud provider and we need to provision some infrastructure, then we will be using maybe infrastructure as code with Terraform models to provision Kubernetes, to provision, I don't know, PG, secrets manager, network, DNS, and everything like this. Then we have another compose, for example, like Helm charts. You are already aware of it, or maybe another tool. So if you're looking at Cert Manager Helm chart, you have some deployment spots, config map, and it's going to be composed and delivered or abstract. Delivered as, and you can just use it with custom definition, putting just few values in it. And also you have parts like, for example, crossplane, V2, where you can now compose natively an application. For example, if you are creating just a simple web application, you will have maybe a deployment, a pod, a config map, a service, an ingress, and all the stuff. And you can compose it also and deliver it to the developer as a custom resource definition. And they just need to create a custom resource of that, maybe put 3 values on it, and it's going to be deployed. I mentioned cross-plane v2 because since the v2 version, it's supported natively and you don't need a provider. This is understanding the compose. And at the next, we are giving you a recap why we are doing this webinar. We will showing at February, we will writing a blog, and we also provide a webinar how to build a Kubernetes cluster with vCluster and GitOps. A lot of people liked it, and we get, I don't know, maybe about 100 messages about different channels, and they ask us, yeah, it was really nice, we get the idea, but how we can build the catalog you show us, or how we can integrate, or how we can reduce the CI part, because there's a lot of magic happening. Can you please provide another webinar, and then we collecting all the requests and say, yeah, it sounds nice. A lot of people are interested in it. Let's do it. And the last setup was looking like, so you understand the CI part, like a developer modify just one file, and depending on how you set up it on pull request or merge, it's gonna be a trigger. And then we have our templater. It's gonna making schema validation, testing, templating, and all the stuff, creating the Terraform, the airbags, the overlays in a GitHub action, and creating then for you the node pools, paint them, deploy the vCluster stuff, just with 3 or 4 lines. It was for the developer. On demand, you're getting ephemeral stages. This is how we built it. And you can see we have a lot on GitHub action, or you can do it the manual way. And of course, the people want to reduce this part. And this is why we are sitting here. You can find a QR code to the repository if you want to take a look on it. So this is a recap. And why we have done it this way, this was a real customer use case. The customer said we have managed Kubernetes clusters, but we need 1 week or 2 weeks because we have tickets to create new cluster. Can you speed it up? And then we are taking a look on the market, seeing, what is available, vCluster, and created ephemeral stages, we call it, to avoid ticket ops. So the developer going to a repository, this is a self-service, putting 3 or 4 lines, create a pull request. The platform team was watching and seeing, okay, really nice, I like it, with some regex schema validation. And then it's going to be getting the ephemeral stage with a dedicated node pool. And because they wanted to use cloud native and pay as you go, and just only to pay for the environment, the developer needed it. And that are the reason why we built it, also to keeping the cost low and creating some multi-tenancy and security by design for soft multi-tenancy. So you know the reason about it. This was a real customer use case, and a lot of people struggling with same issues. This is what a reaction we get after the webinar. But how we are coming from this to a 10-story building built in just 22 hours and 45 minutes. The Broad Group, a Chinese construction company, decided that the usual 1-year period to build a story building simply would not fit to their time frame. So they looked for a much faster option and built for a little more than 1 day. And now you're asking you, why you are telling us this, because I'm show you how much in common we have and how they did it or why they did it. And let's jump to the next slide. If you're looking on this, how they achieve just building 10 layer, you will see you have a prefabrication part. So they compose. This is the first compose layer. You have a foundation, of course. You need a foundation. Then they compose a lot of prefabrication walls, some electricity, and also stuff like Lego bricks. So they just need to deliver it, put it together, and then they have the frame and everything they needed. Then they put another compose layer with the windows, with the doors, and everything you need to make the building complete. And then they also compose a lot of the interior designs. Like you can see a table. So you just have 2 parts, and you have 10 stocks building finished in just 1 day. And we are doing similar stuff if we compose resources, if you take a look. But the you have also, of course, to keep in mind that not only the components on the, how I tell you, not the only components are getting on the compose layer, you have also environment behavior related to all the stuff. So you have, for example, they have to keep simulate the statics, the math works. If it works, created a digital twins. We are also doing a similar part of it. I'm going to show you in a few seconds. Then they have 24/7 to shift work to make it possible, and just-in-time delivery, getting all components they needed to build this house in just one day. So let's translate it, because we are not building houses yet. Let's translate it in our setup, or how we compose it, or how we build it. And as you can see, as a foundation, we will be choosing for this demo StakeIt as a cloud provider, because we need a cloud provider which deliver us some managed services like Kubernetes, DNS, Secrets Manager. And this is going to be our foundation. Just-in-time delivery will be something like if we need a new node pool, or if we need some more VMs or bigger VMs, we just can use it, because it's a hyperscaler, it's a German hyperscaler, and you can use it by just-in-time delivery. This is how you can translate it. And of course, the API working 24/7 if they hit the SLAs. So yeah, and StakeIt is also a member of NeoNephos. NeoNephos is a project by Linux Foundation. Europe, to help Europe to get its open cloud technology, so we can more be independent from big providers and different cloud services. It's going to be announced at the KubeCon Europe, and I found it really interesting, because you have projects like Gartner for handling Kubernetes cluster on different types of systems. Just to mention, I don't know if you heard about it, but I really like the idea, and I'm coming from Europe, so yeah, I found it really interesting. And so, but now let's jump to the next layer. It's going to be the Compose layer, the infrastructure. After we have the cloud or the cloud provider, we need, of course, something like to provision everything we need. And you can choose different approaches. I think the most one are aware of infrastructure as code, using Terraform models or OpenTofu to provision everything you need. For example, like your Kubernetes cluster, DNS, and all the other stuff. But you have also some provider, for example, which works with cross-plane, and you can use cross-plane to define or to deploy everything from Kubernetes based on custom resource definition. So you can also compose in a way of managed infrastructure and provision it about a Kubernetes cluster. But not every service provider supports it. StakeIt have already 2 or 3 implemented provider, if I remember it right, for the Kubernetes engine. And you can do similar with Crow. Crow is Kubernetes resource operator. It's a new player starting, I think I was aware of January this year. So it's really fresh. And if you're using AWS, for example, they have already 50 egg controllers. So you can also use one egg controller is the relationship to one managed service, if I get it right. And you can use it to provision, for example, your Kubernetes cluster, managed database, and secrets manager. This is going to be the Compose layer 0, the infrastructure, after we choose the foundation. Then we have, of course, our Compose layer 2, the third-party tools like Nginx, external secrets operator, cert manager. We need also to compose it. And in the most cases, a lot of tools going to be delivered as Helm charts. And I think a lot of you also will be using Umbrella Helm chart to put some values on it. And you can also, of course, use for this part operator, for example, Cloud Native PG to creating custom resources and also deploy everything you need. In the most cases, you have also the challenge. How do you deploy the operator? And I saw in the most projects, they're using Helm again to deploy the operator, and then the operator to provide the databases. So yeah. And also vCluster is going to be part of a catalog, and the simulation. I'm speaking about the simulation. For example, you need to test a new version of Kubernetes and your cloud provider don't support it. You can just spin up vCluster with a newer version and test it if your application is still working or if something is broken or deploying multiple components. This is what I mean by simulation. It allows you to simulate. Of course, you can also take a dedicated cluster, but it's very easier if it's part of your catalog just to spin up a virtual cluster and test it. This is how we're doing a lot of tests. And then we have, of course, the Compose layer 3, the custom application, or this is the developer part, how you can bring the developer application into the catalog and also allows the developer to deploy their application without doing a lot of CI magic. And if you're taking a look at it, for example, you can use Crossplane v2 or Crow or Kratix to define your custom resource definition and to compose, for example, a web application that have components like Ingress, Pod, config map, netball, and all the other stuff, and allows you to deploy it. You can do similar with Score, but Score is not running or it's not an operator yet. I know it's a issue, open or feature request also to allow Score running on the cluster to generate the manifest. Here you will be used a custom resource, and here you will be used provisioners. They already predefined a lot of stuff. I'm going to show you in the demo how you can use Core and how you use tools like Crow for different use cases, but to achieve the same goal. And so, yeah, it depends on the developer you're working with or the developer teams, which approach they like more, and depending if they have access to a Kubernetes cluster with Crow or not. This is a Compose layer tree. I hope you get the ID. And the next step is going to be how we are coming from the Compose layers to a catalog or what it's. And if you are looking now at all the stages, you will see we have Stackit as a cloud provider. Then we have our Compose layer 1 with Terraform, Crossplane, or another tools. Then we have for the application or third-party tools a Compose layer 2. And then we have again a Compose layer 2 for the developer parts, the application, and with Crossplane, v2, Score, Crow, Kratix, and another one. This is how you can translate it. And let's see what is the pain of the developer. Why we are speaking how we can going away from CI more to a catalog-based approach. If you're looking at the pain of the developer, what are they doing? They build the application, running the test, and doing a lot of another test, and then they have to need to build a Docker image if needed. And maybe your team already covered it with a pipeline using build packs or another tools, but maybe they also need it. But when it comes to delivering the application, they also need to provide Kubernetes manifest, because after the Docker image is built, they need to package it in Kubernetes manifest. And then, yeah, they need to decide what we need: deploy, pod, config map, service, HPA. This is just a simple web app. And after that, they need to choose plain YAML with env sub, or will be using customized or YTT from Carvel or Helm or Timony to package it, to compose it, because they don't want to write every application. If you have, I don't know, 100 microservices or 100 web app services, you don't want to do it all the same to create every time new manifest. So you will package it in a Helm, for example, or if the developer deliver the application for different teams. But then you will also be aware of tools like Helm, Timony, and all other tools to choose wisely. But then it's also not finished. After they choose the manifest, the developer need to be aware of security, how I configure the security context, what is going to be needed, on which infrastructure it's running. For example, if you enforce pod security standards, a lot of application not coming up. I saw it, and they need to be aware of the security context. They need to be understand on what is on request, how I can configure the HPA, horizontal pod autoscaler, and how can I combine it. And then they also need to be aware that a matrix server is running, because if you just create requests on HPA, you need to know that you have a matrix server. If you're running on Edge, it's a little bit difficult as if you are using a managed Kubernetes service, and a lot of stuff. And I mean, it still needs to fit also in GitOps, and they need to choose a tool, Argo CD, Flux CD, Flux customization. You can see a lot of cognitive workload going to the developer, because they also going put it into CI pipelines. And I have support to companies last year to prepare security audit. And after the security audit, yeah, you can say, let's shut down the whole production environment, especially if you're running, for example, for critical infrastructure provider or something like this. In Europe, it's very difficult, because the most security issues coming from the developer application. It's not a blaming, it's just what we find out in the security audits. And I mean, we try to establish IFE culture, we help them, but yeah, it takes a lot of time. And you can see how many times the developer need to spend to how many choices they have, too much cognitive workload. And if you are follow up the last states, or I have searched it, a lot of people say the developer just coding 1 hour per day. GitLab say it's gonna be about 25%. You can Google it if you don't trust me and see. So the developer don't have much time to deliver the work they needed. And we try now to reduce this cognitive workload in for predefined a catalog, and you will see how. Um, and a lot of people also say Kubernetes may be the wrong abstraction layer after the security audits here. A lot of companies coming to me and say, wow, maybe we should switch from Kubernetes because this is the wrong abstraction layer, because we need to cover a lot, we pay a lot, we put a lot on money, and maybe it's the wrong abstraction layer for us. And for some customer, yeah, it fits if you don't have the resource, the knowledge, and don't know how to start it. But if you, and you are a critical infrastructure provider, you don't want to make the experience with critical parts. So yeah, maybe you have solution like Korea, Heroku, or Cloud Foundry, or a new player. Config Hub is now in the game, starting, I don't know, was released 2 or 3 months ago. So for some customer, it fits, and they're very happy. I call it the platformless, because platformless says you don't need having an engineering team if you don't have the budget, but the provider have one. You just need to pay more. But we are here not to speaking about the wrong abstraction layer. We're doing it with Kubernetes and try to catch the developer and help them to reduce the pain. And this is how the most setups I was working looks like. You have the developer, they define some parts of the application in a CI pipeline, and then they have deploy, port, config map, and all the stuff I already mentioned. Packages with plain manifest, or putting Helm, or using YTT to patch Helm to creating the manifest. I saw a lot of that. So, and then the platform engineering team, of course, will provide a host cluster, and Argo CD gonna deploy all the stuff. And if they want to use Timony or another tools like YTT, they need to enable the plugins, or tell the platform team you need to enable it. This is, you can see, you have a lot pain going on for the developer, and how you can reduce it without building the next 100 IDP, internal developer platform, not identity provider. So yeah, from CI to catalog, how we build it and how we try to understand the real pain of the developer. We created, as a platform engineering team, we created a custom resource definition, and we also created some, as you can see here, some provisioners and patchers in Score. So the developer just need to define a custom resource, or using Score as CLI, and just provide one file with few lines of code and getting an opinionated way, web application, for example, with best practices, with some requests. I'm not saying that the application I'm going to show you is bulletproof, but you can see a lot of things are already setting, like security context, like health checks and other stuff, and making it configurable. This is what we try to achieve here, to put a lot away from the CI part to putting in a catalog. So they don't need to trigger one CI after another CI if a step is finished, and also waste a lot of money running the pipelines. Yeah, the demo requirements are just easy. If you are listening to the developer, you really ask the developers, they say, I need a streamlined GitOps-driven environment to deploy services quickly with minimal overhead, allowing me to work efficiently on my task. Very easy. You just need to listen to them. And they tell you, don't build an internal developer if they platform if they don't need it at the moment, and try to figure out the pain of the developer. Ask with them, make a shadowing. This is how we do it. We shadow the developer to understand the real needs and where we can create real value. And this part, it's a real pain. It's not just a use case. We say, oh, it sounds funny, let's build it. It's a really pain. We imagine, or we saw a lot of different customer, a lot of different environments, and yeah. So let's jump on the demo. I'm going share my another
So
screen, so we
that was a lot to get
yeah.
through, right? Like it's recorded. You can go back. You can look at any of those sections. There's gonna be slides and stuff like that too. But I thought these were full stack developers, right? Like, they want to do all this stuff. They want to get their hands dirty and mess around with stuff. That's like way too much to pick from, right?
Yeah, of course. I mean, if they're working more than 8 hours a day, they are welcome. But I work with a lot of developers. They want just code, really. I meet a lot of developers, they just say code, Docker, and maybe Kubernetes manifest to read it, but we don't want to do all the other heavy stuff and be responsible for the security because we have a platform team, and the platform team getting nice salaries if you're looking at the table for the salaries of the platform engineers. So why they don't help us? They should, because they provide the platform. Yeah, it's kind of a discussion, kind of. So welcome to the demo. And as you can see, everything we already saw on the slides. Now you can see in a folder structure here. We have a layer 0, the Terraform. We have a Helm for the layer 2, and we have Crow, Kratix, Core, and all the stuff. But let's, to get the whole picture, let's start. We have the foundation, we have the cloud provider. We have nothing. So we need to start. We are gonna to choose some tools to using the Compos layer 0. This is how we done it in this demo. We, as platform engineer, define, for example, just one config YAML. You can see we love just one file and one environment files for some secret. And we have written an engine. We call it engine. It's a Go binary. So the developer, after they put everything they needed or everything they're gonna be requested, they run the engine, and the engine binary gonna create and template the Terraform folder, the managed Helm charts, the umbrella Helm charts, the customer overlays, doing all the schema validation, all the stuff. Also creating some, how I call it. You have a managed umbrella Helm charts. It's our opinionated weight from us, but we still to make it customized for every layer on top. So you can configure it like you like if you don't like our setup. And then, of course, you need to start it. After everything is created, we start the engine another round, and the engine is gonna be, okay, well, if I'm finished with templating, the engine gonna use the templated Terraform folder and deploy, for example, the Kubernetes, the managed Kubernetes cluster, the node pools, everything you needed, secret store, DNS, everything you need from the cloud provider. Then the engine taking the kube config of the managed cluster. You need to solve a chicken egg problem. You can't use crossplane if you don't have a Kubernetes cluster, because where do you want to run the controller? So we're using Terraform for that. And because a lot of people say, yeah, but can we solve it with crossplane? At the moment, no, you can't. You need a cluster. And after that, everything, it's gonna be bootstrap. The Argo CD, the engine, starting with the kube config and deploy Argo CD. And Argo CD will use application sets, and based on the labels, for example, the cluster, the managed cluster where Argo is running, is labeled with yellow and blue one, and the blue one is cert manager, the another one is external secret, and gonna bootstrap the whole stack on the managed cluster, everything you needed to do your work. So, and then Argo starting to manage itself. Hopefully you get the idea how we bootstrap the control plane.
All right, we had some questions, Artem. People want to know, can they get access to the GitHub repository? But for right now, there's a lot of stuff in the GitHub repository that is related to your configuration and your setup. So not right now. Some of the stuff's available, like from the last, I think the last webinar and stuff like that too, which you'll get to. But it's not public yet. We'll say that.
It's not public yet, yeah. Yeah, I will publish some parts, and just follow us later on LinkedIn, or on LinkedIn. It's gonna be the easiest way. I'm gonna abstract it, and we need some parts I can't publish, and I am try to publish everything so you get the idea and can build it by your own. But let's continue. This is how we build this part. So this engine, Go binary, very easy to use. The people starting it really like it. And yeah, there's some rumors that it's gonna be maybe public in the future, maybe not. So yeah, just follow and see what's happening. After that, you need, of course, to deploy the vCluster, because at the moment we have a managed cluster with every tools you have. Then you need to deploy the vCluster. And how we do it, we creating an app of apps pattern. App of apps pattern is, you have a pointer, an Argo CD pointer. It's the easy way to explain it, to a folder. And in the folder, you have different application. Here we have the vCluster application, and Argo gonna deploy the vClusters with the toleration and everything you need. This part, the apps is not gonna be templating. The rest is templating, not depending how many cluster you have, but the app of apps pattern, I put it manual way, so it's not part of the engine yet. Maybe we integrate it, maybe not. I know it's on our roadmap, but I don't know when we are going implement it. And Argo CD deploys a vCluster. So every vCluster have a dedicated node pool, and we can deploy the workload on it. And after, I think it's gonna be clear here. Now we have a managed Kubernetes cluster, different vClusters with node pools, but we don't have a relationship yet between Argo CD and the vCluster, because we also want to using the application sets based on labels to deploy it to the virtual cluster like you will do it on the cluster dedicated cluster. And how we solve this challenge? We are using external secrets operator, like I mentioned, and we have a relationship to a secrets manager or Vault, because it's the implementation is based on Vault, is running on Stackit. And what we are doing it, we creating, if a vCluster is created, we have a kube config, we push it to the secrets manager, and then we are using external secrets operator, creating external secrets with labels. And based on the labels, Argo CD gonna get access to the vCluster, looking at the label, seeing, oh, I saw the label, it's gonna be labeled Crow, so I need to deploy Crow for this part. As you can see, project is gonna be labeled with Crow, and Argo CD gonna deploy Crow. And I have forgot to mention, sorry, you can see on this icon here that this is going to be the part of the platform engineering. The developer have another one, but yeah, this is going to be the part for the platform engineering, like the parts before. Sorry for that.
We got a question, Artem. So it says SKE only supports one node pool. How do you set up multiple node pools? So these are node pools for vCluster, right?
No, they support multiple node pools. I can show you because I've set it up. I can show you. Wait, let me. We are going through the folder structure. Then I'm going to show you. I have two dedicated node pools. I don't. It's Gardener. They're using Gardener, and they support multiple node pools. Maybe it's information is deprecated, but yeah, I'm aware of it since I don't know 1 year. But yeah, another topic. So let's continue. For example, we have here now the compose layer. It's called 2 and 3. Why it's going called 2 and 3? Because we don't just deliver the third-party tools. We also doing things like if you are going looking as a managed catalog, they are just Helm umbrella charts. And take a look at Crow. You can see at the templates we have already defined. It's called resource graph definition for the developer. As a platform team, we already deliver some best practices so the developer can just create a custom resource and deploy it. So because of that, you have the compose layer 2 and 3, and you can see we're using pod security standards under here at this point, and we have also something like security context set. Like I said, it's not maybe the best example or the bulletproof, but it's better than the developer just started it and they can just deploy on web application, and or maybe you can use this this inspiration to build another parts. So let's jump back to this. So we have a managed Kubernetes cluster running on it. Argo CD, all the third-party tools have deployed vCluster, connected to it, deployed Crow on it. And now what we are going to do in the next part, of course, now it's the developer part is coming. You can see the icon is changed. So how can I, as developer, deploy it to this dedicated cluster? We establish a multi-tenancy approach here. So the developer define just one YAML file, put it in a web app, because for to make it simple for you to follow up, I just created all the folder structure here to web app, and Argo CD connected. It have an open application, an open project, an open repo access to the dedicated vCluster. So it's project scoped. If a developer try to use another repository or another destination cluster in Argo, you can say with project which resources are allowed, which definitions or which destinations are allowed, and you can blacklist and whitelist resources and create something like this. So we created for every dedicated cluster or for every virtual cluster, we create this three couple of project, Argo CD project, application, and also not just the application, also the how it's called, the repository. So sorry. And then Argo CD gonna deploy this web application. If we are looking at this part, we have our initial pointer, just one for dedicated to this file and this folder structure. You can see the developer just need to define one web application because we call it Crow allows you to writing custom resource definition without writing custom resource definition using the resource graph definition created, the CRDs for you. And the developer just need to put things like this on, and they're gonna getting the application. I'm gonna show you how it looks like in few seconds. Yeah, this is the approach how you can use it, for example, with web application, with tools like Crow, or with tools like Kratix, Crossplane V2, and I call it the operator-based approach. Don't know how to call it better. So yeah, Crow helps you to define your custom resources easily, no coding required. And Kratix, in my opinion, has a little bit another approach. I am also building the demos for you for that, but we don't have much time to show you all the stuff. So yeah, Kratix lets you build more API-driven, I had the feeling, approach to create your own APIs by composing the resources, and Crossplane abstract not only apps, but also infrastructure. So if you have a cloud provider supporting Crossplane managed infrastructure parts, you can also create, for example, the Kubernetes, the managed Kubernetes, and provide the kube config directly to Argo CD and label it with some magic happen or with some logic, and don't need an external secrets operator. This is how you can use the tools. And then we have another player here, Score. What I like about Score, a lot of developers don't have access to the cluster and want to test or to create the manifest outside. And Score you can use not just you can use without the operator, and also for Docker Compose. If you don't have Kubernetes, you can use similar way for Docker Compose. The easy way to explain Score is you define, they've already predefined some provisioners, but you as platform engineers define some custom provisioner like ingress controller, like HPA, and you define some patches if you need to patch a security context for already existing provisioner. And then the developer using the Score CLI, init it, getting a state already, again, just one file. And then it's going to be created now, not a custom resources, but the finished manifest. Then they can put it to Git, and Argo CD going to deploy it. It's going to be the Y cluster, not the X cluster. I have a typo here. Yeah. And if you like to see it live, I think we have some minutes left, if I get it right. I don't track the time, but I think we have some minutes left. How it looks like, you just have a Score init. You're giving him the provisioner. I'm using a custom provisioner and some patch templates. We are gonna provide both examples. They're already public. We are gonna share with you the links, or if you Google Score K8S web app or something like this, but we are gonna share with it. They're already public. And yeah, this is how the Score files looks like. We are going using, and the next step, wait, give me a sec. So we init now the Score part without having access to a Kubernetes cluster. It's have a state, it's have the default provisioner and our provisioner. So in the next step, we will be using the Score file. And in the Score file, you can see, for example, it's just few lines. It's more lines than for the Crow part, but this is because I configure it to pass through the namespace. If you remove all this part, you're getting, I don't know, maybe 15 lines as a developer you need to write, and you are finished that. So let's create a generate application by using the Score YAML and also patch a namespace we want to have. And you can see we are getting an application. I'm doing a typo because I forgot to remove the service account for the custom provisioners. So sorry for that. And then you are finished. You get the resources. You can put it to Git, for example, Git add Git commit init push. I don't know, Git push. And now we let Argo doing the job, and then we are taking a look in a few seconds. I think you will know something about the folder structure. Maybe not. I'm going to show you about the folder structure so you can see how we built it. the binary gonna create the Terraform models over delivered here, because if you are running air-gapped or another infrastructure, maybe you need the models local. It's gonna create the Terraform models. It's gonna create the platform with our opinionated way already configured, and you can just override everything you need, like here, creating 2 node pools, as you can count, 1, and it's gonna be a second one. So it works. We have 2 node pools. If you can see, right? Let me prove it. If you can see, you have different nodes with different node pools. We have infra, we have X, we have Y. So I don't know where the information coming. They don't support it. And we have also running, if we are going, for example, to the vCluster project, looking, they are running on the X. They're running on the, because we set some toleration and some taints, and you can see the core DNS and the vCluster part is running on the X. I see I don't set the toleration, the taints for the infra nodes, so the workload also should be scheduled just on the node pool X. So this part works. And a similar way we are doing it with the umbrella Helm charts. As you can see, it's very easy. We have an opinionated way how to configure parts. And then we have the template engine, or the engine gonna create, for example, I call it the control plane, gonna create for you the overlays. You don't need to do anything. You can also override the values, all the magic happening here. And we are not replace it for day 2 operation. We're making a YAML deep merge. So if a customer say, I want to put, I don't know, some things here based on whatever I like, so we don't remove it, we just merge it. And the magic happening here by the cluster, how we create, not clusters, how we create the external secrets, or how we connect Argo CD with over the external secrets. With the cluster, we create here additional labels, or we have a cluster part, we templated also compose this, and then we reference the secret store, and we ref the key. It's going to be my cluster, and the kube config for the vCluster project X, it's going to be project X, and we set the label enable crow, and it looks like in cluster like, let me show you on Argo CD. It's going to be, looks like this one. It's going to having the label sets, also provided the labels. You can see we escaping, doing a lot of magic to getting on the kube config. And if you're looking at the secret created from that, wait, let me just putting the Argo CD namespace, looking at the secret, you will see Argo CD project X. I'm going to describe. You can see the label crow is enabled. So this is how the magic works. But this part, it's not going to be how the platform works. I know you have a lot of questions. A lot of people ask me, please share it with us. Please share it with us. We are going to do another one, but this is not the part of it. The part is to reduce the headache of the developer. Yeah, and this is what we try to achieve. And let's take a last look at
reducing the developer and increasing the platform engineer, right? So we had a couple other questions too. So is there a way to use Terraform instead of cross-plane? We've already created custom Terraform modules. So this is just your opinion way of doing it. You can do things differently than this demo, right?
Yeah, of course, you can do it. Let me answer the question after I finish this part, because I think it's going to be easier for me to follow up. And thank you very much. But yeah, let's keep the question in mind. As we can see, this is a control plane cluster running everything. We have OAuth, we have opinionated way, we expose ingresses, but you can just access it. And if we are going to the core application, you will see, tada, we have a core application running. I don't know if the score application already running. Yeah, it's running already, also deployed to it. And you can see I destroy the limit because I tested the demo, I don't know, the 3-4 days, more than 5 times. So yeah, I'm on the limit here. So this is how it's worked. Yeah, I got no certs because I'm rate limited by Let's Encrypt. So yeah. A short recap, I think it's gonna be very easy. vCluster enables fast, like with Kubernetes isolation, compose layer from infra tools apps, shift from CI pipelines to GitOps driven. delivery through our Kubernetes service native catalog. Now, hopefully, you know what we are meaning by catalog. Developer needs fewer decision, more self-service, not the next IDP. Choose the right abstraction layer for your platform and developer workflows. And now we are going, here's a little bit, here's our outlook. I already teaser it. We are going to build in the future, because we get also a lot of requests on it, to show the people how they can build from scratch what we are building it with, using the binary or using another approach. Maybe I'm gonna building a Python template or something like this. You can use it, and we are going, I don't know, we need 2 hours, I think, for the next workshop to going through all the stuff and showing you how all the components fit together, how we abstract it, and all the magic behind it. Now I just want to give you the impression how we done it, and I just needed 30 minutes to set up the whole infrastructure, the whole setup, everything you saw it. I just needed 30 minutes, thanks to the binary and thanks to the pre-work of, I'm not doing it alone, with my team, and the team composed a lot for me, so I can already use it. Now we are coming to the questions.
All right, let's do some questions. All right, so can I use Terraform instead of Crossplane? I've already got Terraform modules.
I'm not an expert in crossplane, but if you are, what are doing crossplane, if I understood it right, in the most use cases, you can use, if you already have a Terraform provider, you can leverage this Terraform provider with some cross-plane specification and use it already. This is how the most companies do it, and this is how I think Stackit do it with the cross-plane provider they're writing on it. They just leverage the
Terraform tool that converts it, right?
Yeah, it's like converted, but like I say, I'm not an expert. Ask Victor Hahn.
Yeah,
he loves to tell you about. It's Victor. So, hi, Victor. So this is how I understand it and how I see it. Maybe I'm wrong, maybe not, but a lot of companies building provider are using over leverage it, and do it using the already existing Terraform provider. This is how I saw it, but I don't deep dive in the code. So
yeah. All right, we got a general comment too. Is like, this feels like a big mixed pot of all the DevOps tools. It's a lot of tools. It's a lot of tools in there.
Yeah, it's a lot of tools, but you need also a lot of tools to bring in, for example, your application running. You need a policy engine, you need observability stack, you need a lot of stuff. And because of that, we are using the vCluster or dedicated cluster based on the labels to create a leaner platform just for the developer, also to keep the costs down and keeps the multi-tenancy strict between. This is but I think every one of you who is building Kubernetes or started with Kubernetes, you will need Cert Manager, you will need an ingress controller. If you don't using Cilium as CNI or not allowed it, you will need an external DNS, you will need a policy engine with Kyverno, you will need a lot of stuff. You will need Argo to deploy it and all the other tools. And I think at this cluster, it's gonna running. I don't want to lie. Just like take a look because I mean we are live and we can say, let's set me the filter. It's gonna be the control plane, and you can see which tools are running here already. We have external DNS, Cert Manager, Argo CD, external secrets operator. We have the Hummer dashboard. You saw here. It's going to create on demand also the application and everything you needed. It's not an IDP, but it helps the people a lot. It's a collection of all the tools you have deployed. Yeah, you have the Nginx, Ingress policies, Kyverno reporter for having the UI and all the stuff, and the Kubernetes stack, and I think some Loki and all the stuff. So yeah,
we had another question. How long did it take for you to build all this stuff for this demo or for this like use case that you were doing? Like how long? Like a couple weeks? Like
we reuse a lot of components, so it's take us to build, I think, to combine the experience to find the way are we choosing app of apps or are we choosing application set? I think we built it in 2 or 3 months, but I'm also working with very experienced people. So the most the decision was like political ways, and we have to discuss a lot. But the implementing part take us maybe 2 months to build everything. Also the Go binary, it's just a first version. It's do a lot of works, but it's still a lot of improve going on, and now we are using it internally with a user base, and the user started to testing it, and you get a lot of feature requests, like it's a product now. So it's
So
gonna
two
be
to
a
3 months
product.
of work, but then like 10 years of experience behind that, and then like a lot
Yeah,
of that is
yeah.
just figuring out what tool
So
you're going to use, and then the implementation's a little bit quicker, right?
yeah,
All right.
yeah. So
So
we
Upjet is used to create cross plane providers from Terraform ones. All right. So that was the name of the tool, Upjet. All right. So what's the biggest challenge with this setup right now? You consider it production ready? Like, is production ready for users to send production stuff, or for testing? Like, what is this for?
Yeah, we already use it for production stuff. I mean,
Perfect.
not the vCluster. We are using it for some testing and testing new versions because we have the most requirements are for dedicated cluster, but sometimes we also get for shared cluster to test new features, all the stuff. It's already production ready. We use it on the daily basis. We used it before, but not at this nice setup, but we use it already before. Now we integrate it into a binary to allow new platform engineers to start as fast as possible, because my customer now not just only the developer, I serve also the developer and the platform engineers, and we provide this binary, this opinionated way, so they can run it air-gapped, on edge, and also on the cloud. We tested it on edge a lot, and on edge is a lot of fun, I can tell you. So yeah, it's already production ready.
And that binary may be accessible in the future, maybe? I don't know, like something?
I
We don't
need to
know.
discuss this internally. We don't know. We have some ideas. It's not like we don't want to share it. It's just we just started to
Yeah.
define it, to build it, and it's still work in progress. So just follow up, and maybe I can tell you the next webinar more about it, and also show more about it, how it works, how we use it. It's gonna be the idea of the next webinar. I think is a
Yeah.
lot of most people love it, to see how you can really from scratch. You have nothing, you have just an empty repo, and how we can provide all the platform and set up like this based on top of it. So yeah.
We need more time for Q&A next time. I know we got a couple other questions. Most of them are like comments and stuff, but we're kind of over time. So let's go ahead and if you have these questions, reach out to either Artem or myself, and you can ask them there. If it's about like the demo and stuff like that, obviously reach out to Artem. If it's about vCluster, reach out to me, and we'll hook up with the right people. Artem, you want to show the next webinar? I'm gonna deliver our outro because like I said, we're over time. Can you bring up the webinar on the fourth tab? That one,
Yeah,
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 there you
yeah,
go.
of course.
All
So,
right,
so
so I'll
now I
do the
can
outro.
follow.
So yeah, join us for another webinar coming up on the 28th. Right? Oh, there's a link too. Yeah, join us for this other webinar coming up on the 28th. It's going to be talking about moving from VM-based Kubernetes to bare metal Kubernetes, which a lot of people are thinking about now, right? Like with the changes to how they get their VMs and how expensive it's getting. But anyways, let's go back to the slides. Let's do an outro, and I want you to be able to say goodbye and everything, Artem, because there's a lot of good information. You want to go to the next slide? All right, yeah.
Yeah,
So info and QA, we
it's
already did QA, but let me hand it back to you, and then I'll do our outro.
okay. Yeah. We will giving, like I said. Also, I will giving at the platform call a workshop how to build IDP with GitOps and vCluster. If some of you joining it, if some of you need a voucher or something like this to getting some discount, just ask me about LinkedIn, and we are doing the midsummer webinar where we show you fully GitOps driven approach and how to use the binary or maybe another one depending on it. And also I will giving a book signing on the container days, and I think also giving a book signing on the KubeCon NA Atlanta. Yeah, for sure. We're doing a book signing. The people love book signings. So yeah, see you there. Now I'm finished. And thank you very much for attending and giving me 1 hour of your time. Hopefully you get a lot of knowledge, and just ask me if you have some questions about LinkedIn. So Mike, I place
It
the
was
ball
it was a lot of
back to
stuff,
you.
right? Like I'm still
Yeah.
like I learned a lot. I learned a lot on this too, and like I was trying to keep up because there's so much stuff on there, and you went through it pretty quick. So yeah, go back, rewatch this on the Linux Foundation's YouTube channel, right? Like join us on Slack. You can scan that for vClusters, slack.vcluster.com if you have questions or anything like that. And like I said, yeah, go to the next webinar, and then keep an eye out on Artem's LinkedIn for information about the GitHub repository and stuff in the future. But I think that's about all that we have. Thank you so much, Artem. Let's go ahead and hand it back to the Linux Foundation and let them close this out for us.
Thank you so much, Mike and Artem, for your time today, and thank you everyone for joining us. As a reminder, this recording will be on the Linux Foundation's YouTube page later today. We hope you join us for future webinars, and have a wonderful day.